In this video, we will solve two equations by factoring. The first equation that we will solve in part A is n squared minus 12n equals negative 35. To solve this equation, we first need to set the equation equal to 0. To set it equal to 0, we will add 35 to both sides of the equation. This will give us n squared minus 12n plus 35 equals 0. In terms of factoring n squared minus 12n plus 35, we want to first think about a greatest common factor. In this case, the greatest common factor is 1. Next, we want to recognize we are dealing with a trinomial, and it's a trinomial where a is equal to 1. So we need to answer the question, what multiplies to make c and adds to make b? Our c value here is 35. Since c is equal to 35, we need two numbers that multiply to make 35 and add to make negative 12. Since 35 is positive, the numbers will have the same sign. Since 12 is negative, they will both be negative numbers. So negative 1 times negative 35 is positive 35, but that does not add up to make negative 12. On the other hand, negative 5 times negative 7 multiplies to make positive 35 and adds to make negative 12. So we can factor our n squared minus 12n plus 35 as n minus 5 times n minus 7. Now that this is factored, we can separate the equation into each of its individual factors and set each individual factor equal to 0. So either n minus 5 equals 0 or n minus 7 equals 0. To solve n minus 5 equals 0, we'll add 5 to both sides of the equation. To solve n minus 7 equals 0, we'll add 7 to both sides of the equation. This gives us our two solutions, 5 and 7. Again, you should check that 5 and 7 are both actually solutions for this equation by substituting them in one at a time into the original equation. Once you have verified that 5 and 7 are the solutions for this equation, you then give your conclusion. The solution set is the set 5, 7. In part B, we have the equation y squared equals 8 times the quantity y minus 2. We need to begin by setting this equation equal to 0, so we could do that by subtracting 8 times the quantity y minus 2 from both sides of the equation, and doing so would give us y squared minus 8 times the quantity y minus 2 equals 0. While we have set it equal to 0, this is not yet in the standard form. We need to get rid of the parentheses around the y minus 2. So we'll do that by distributing negative 8 into the parentheses. So negative 8 times y is minus 8y. Negative 8 times negative 2 is a positive 16. So the new version of this equation in standard form is y squared minus 8y plus 16 equals 0. We can now proceed with our usual factoring process. The GCF in this case is again going to be 1. We also recognize this is a trinomial. It's a trinomial again with a leading coefficient of 1, so it's a nicer one to factor. So my c value that I'm working with is 16. So the question becomes, what multiplies to make 16 and adds to make negative 8? Again, we have a situation where the 16 is positive, so the sign on the two numbers, on the two factors, will have to both be the same, and since they add to make a negative, they will both have to be a negative. Things that multiply to make 16 and add to make negative 8 is negative 4 and negative 4. So we can factor y squared minus 8y plus 16 as y minus 4 times y minus 4. So now we have y minus 4 times y minus 4 equals 0, and we can separate these two factors from each other and set each one individually equal to 0. Since both factors in the polynomial are the same, we don't need to do the work twice. Separating out y minus 4 equal to 0 and the other one y minus 4 equals 0, we can just do it once. So we'll set that common factor equal to 0, and to solve y minus 4 equals 0, we'll add 4 to both sides of the equation. More often than not when we solve quadratic equations, there are often two solutions, but there will be times where there is one solution. Later on in the term, we'll see a visual reason why this can happen. But for now, we'll finish with our conclusion once you have checked that 4 is actually the solution for this equation. Once you have verified this, just finish with your conclusion. The solution set is the set 4.